Hello and welcome to part 2 of this series on C++. This is a continuation of part 1 which we previously did, and I would like to thank you so much for all the likes and all the support you guys have done. Now, in part 2, we're going to talk about more advanced C++ stuff like pointers to object-oriented programming, meaning that we're going to talk about structures and classes and, method overloading, overriding, virtual methods, and all these kind of good stuff. Now, this lecture goes really into the details of object-oriented programming and stuff like pointers and addresses. So we're going to really look at the basic details of what every programmer should know about pointers and object-oriented programming. So without further ado, let's get started.
Okay, let's talk a bit about pointers. Let's go first to the whiteboard and explain what pointers are. So let's say you declared an int a is 2, for example. So I'm going to divide this part for the coding and here for memory. Code and memory. So in a naive sense, what happens is that the compiler reserves certain amount of memory for a. So this is a box or a memory address stored for a. And the value 2 is assigned to a at this line of code. Let's say you change the value of a to 3 at a certain point of your code. Then what happens is that a is now 3, right? Now, a natural question here is how much memory is allocated for a? Well, since a is declared as an int, then we have 4 bytes, which is 32 bits, right? Because each byte is equal to 8 bits. And this memory size is static. It does not change because it's an int. And an int has a fixed amount of size of memory allocated to it. Floats have different sizes. Double has another size. Long ints as well. If you're interested to know how much memory is allocated to each of those data types, I found this link right here really useful, even though it says C programming, but the size of data types is the same. So if you go down here, you can see that 1 byte or 8 bits is allocated for a char. And since there's 8 bits, then the range of values are from 0 to 2 power 8 minus 1, which is 2 power 8, 256 minus 1, it's 255, as you can see here. Ints have 4 bytes. Older computers, it used to have 2 bytes. You could see also that floats are 4 bytes, doubles are 8 bytes, and so on. Now, why am I saying this? How does this relate to pointers? Well, a pointer, if you want to define a pointer, int star b is a pointer. And the way you should think about a pointer is that it really points towards an address. So if I wanted to point towards the address of A, if I wanted to point towards this box right here, all I have to do is to say it's equal to the address of A, as so. So this is the AND. And what happens behind the scenes is that B will come and point at A, as so. So B is also another box which contains the address of A. So let's say the address of A is something like 0xAB01. So the address is written in hexadecimal notation. The numbers that you use in your daily life, which are 1, 2, 3, 10, 11, 1010, and so on, are written in decimal notation. There's other types of notation like writing numbers in a binary basis. So 1 would be 0, 1, or simply 1. 2 would be 1, 0. 3 would be 1, 1. 4 would be 1, 0, 0. And so on. And how we represent numbers in their binary bases is, let's say 100 is 1 times 2 power 2 because it is at position 2 plus 0 times 2 power 1 plus 0 times 2 power 0, which is 2 power 2, which is 4, right? So we're converting from binary to decimal notation. So pick any number in decimal notation. Let's say the number 512. So how would you write that in decimal notation? So simply it's 5 times 10, decimal is to the base 10, binary is to the base 2. So 10 power 2 plus 1 times 10 power 1 plus 2 times 10 power 0, which if you compute on a calculator, it's simply 512, right? On the other hand, hexadecimal is to the base 16. So a number 512 in hexadecimal is 5 times 16 to the power 2 plus 1 times 16 to the power 1 plus 2 times 16 to the power 0. And since it's 16, means you have 16 digits, if you will, which are 0 up till 9. Then you have A, B, C, D, E, F. So you have the alphabets as well. So from 0 till 9, there's 10, 11, 12, 13, 14, 15, 16. Which means that you could write a number in hexadecimal as A12. This is a valid number in hexadecimal notation, which simply means that A is 10, okay? It's treated as the number 10. So 10 times 16 power 2 plus 1 times 16 power 1 plus 2 times 16 power 0. Also B is treated as 11, C is treated as 12, 13, 14, and 15. I'm telling you that is because the address right here is expressed in hexadecimal notation. It's good to know that because we'll see during the code that when I print the value of B, it's not 3, it's a hexadecimal representation of the address of A. When do we use pointers? Pointers are everywhere. Binary trees, doubly linked lists, queues and stacks as well. They all use pointers. And even though if we didn't say it when we talked about arrays, and let's say an array of size, let's say 5 is equal to blah blah blah, array is implicitly a pointer. An array is a container of fixed size. We assign the following values. Array is actually a pointer towards the first element of the list. So arrays are actually pointers. If you use array as so, if you want to print out array as so without saying which index, this means that you're printing the address of 10. This is what it is. So array is also a pointer that contains some hexadecimal representation of the address of the first element of the array. Now let's see what we can do with pointers. Let's go to the code right here. Create a new file. So let's say I have a number, print that number out, run to make sure everything is okay. Now let's say you would like to declare a pointer towards your number, pointer number. So the way you would do that is you would include an asterisk saying that this is a pointer towards the address of your number. So let's try printing pointer number, run. So as you can see, it's a hexadecimal representation of the memory where number is stored. So what does that mean? It means that I could simply print the value as well of pointer number. So asterisk before pointer number simply means that print the value stored in the memory address, this one. So run, we're going to get 1, right? Because we're pointing at number and number contains 1, so the value of pointer number is 1. What does that mean? It means you could change the value of number without having to say number is equal to something, like number is 2. You don't have to do that. You could do this. Value of pointer number is 2. Now let's check what number is right now. Is it still 1 or is it 2? Run. It's 2 because we changed it using the pointer. Could you have done so using another normal integer? Let's say an int, another number is equal to number. At this point it's 2, so print it out, run, it's 2. If I say another number is 3, would number change? No, it will not, because another number is something totally independent from number. It's located at another memory address. They're not linked to each other using some sort of pointer or something, no. So let me remove this another number because I think I made my point using this block of code. Okay, so basically what we did right now is declare the number, declare the pointer that points at this number, change the value of pointer number as so, and printed number and saw that number indeed changes. Let's declare an array and let's print out array as so. So what do we get? We get also a hexadecimal representation of the memory address of array, which means that array is pointing at the first entry of the array. To keep track of all the array, we have to point at the first element of the array, right? So what happens if I do this? Int array pointer is equal to array, int star, because it's a pointer, right? Cout, let's print array pointer. As you can see, they both hold the same address because they're both pointing at the same location, right? So they're both similar pointers. Using array pointer, I could loop over the list, the array I have right here. So what I can do is this. So let me do for int I equals 0, I less than 5, I plus plus. And at each iteration, let me not only print array pointer, I'm going to also print the value. So the value of array pointer, insert a comma for clarity, and the value of array pointer as so. So what I'm doing here is printing array pointer, which is the address of the current array pointer, and the value of the array pointer. And also I'm incrementing array pointer. I'll show you what incrementing a pointer means. So run. So here I'm pointing towards array because at this point array pointer and array are pointing towards the same int or integer location. So this is the memory address of the first location or the first entry of array, which is 10. Then upon incrementing, I'm not adding 1. Incrementing a pointer is totally different from incrementing an integer. It means go to the next memory address, which is, in our case, an int. So incrementing from one int address to another one is jumping 4 bytes, as so. As we said here, an int has 4 bytes, right? So incrementing or jumping from one int memory address to another one is adding 4 bytes. So let me show you what I mean. Let's go here again. So this is the memory address or a block of memory. So right here, let's say I have a complicated hexa notation that ends with 10. Then here we will have 14 because this is allocated 4 bytes. Then the next one is 18 and so on. So as we can see here, we have 90, 94, 98. Then 98 plus 4 is 9C. So count 8, 9, A, B, C. Then add 4 to C, C, D, E, F. Then you have, the 1 here. 9 would become A. We'd have a 0 here. And you can see the corresponding values, right? That's the basics of pointers. Let me comment everything out. What else could you use pointers for? So let's say I have a function, right? Void do something and pass it a value a or an integer a and change the value of a within the block of code to 100. Now let's declare an int a. Note that everything is commented here, so I'm going to start from scratch. Int a is 1. Print a before executing the function. Run. So a is 1. Do something is the name of my function. Pass it a. Then print this message after executing. Oh, but what just happened? A is still 1. So what happened is that when you write a function and you change values or affect the value of certain arguments, they will not be changed upon execution of the function. Within the function, a is 100. So let me throw out a within the function a is a. So within the function a is 100, but after executing the function a goes back to its normal value, to its latest value, which is 1. However, if you pass it by reference, if you pass the address of a as so, things are totally different. And here's what I mean. Run. A is 100. So if you want your values to change after the execution of the function, you have two options. This is the first option, passing an integer by reference or by its address, or you could do something else. Void do something else. Int star a, you could pass a pointer and change the value of the pointer as so. Within the function, the value of a is, because a is now a pointer, right? So if you want to change the value of a, declare it as a pointer, then here print the value, and here you'd have to, and here I cannot say int star a is 1, right? Because it's a, so int a, the value of a is 1, as so, and here do something else. Run, and there you have it. So as you can see, pointers also get affected within a function, so which means that their value is changed within a function. Now that being said, since arrays, so int array, let me copy paste the array I had here, int array 5, and let's pass an array to void do something for arrays. So the way you pass an array to a function is by int a as so. So let's say I would like to change this, the first value of my array. Would that do the trick? Let's pass the array. So do something for arrays, pass the array. Then let's print out all the elements of the array. For int I 0, I less than 5, I plus plus, C out, array I as so is equal to array I and L, and go. And there you can see it, that the first value has been changed. So since an array, as we said, is a pointer, means that if you change values of arrays within a function, the values will change. So that's basically it for pointers. Those are the basics that you should always keep in mind. How to change a value of another variable using pointers. What does a pointer hold in its content, which is a hexadecimal representation of the memory address. Arrays are also pointers. They're regarded as pointers. We could loop over the array as so, using pointers. And the value of the array pointer is the hexadecimal representation of the first entry right here, the first entry of the array. And last but not least, functions. If you pass an int to a function and change the value of that variable within the function, it will not be affected upon execution of the function. There's two ways of doing so, i.e. if you want to change the value after the function has been executed or you're done executing the function, you could do so by passing it using the address or by a pointer. Perfect. Let's talk about structs. So you'd want to use structs when you've got a bunch of variables or even methods that are related to one another. So let's say I would like to create a struct that models some sort of car. I forgot a semicolon here. So this is the blueprint of a struct. So struct, the keyword, followed by the name of your structure, car, and within the scope of a struct, you've got some sort of properties related to the struct. Let's say you'd like to define int number of wheels, and you would like to have some sort of name or brand of your car, Mercedes or BMW, and so on. You'd also like to know the color of your car, right? What else? You also would like to keep track of, I don't know, max speed. You'd like to save max speed, and so on. You also could do some stuff like void print properties. So cout, let's start by printing the brand is brand. Let's say you'd want to print the number of wheels. You also want to know the color of the car is, and max speed is max speed, right? Okay, so how do I go and create this struct? All I have to do is, like I say, int x. The type of this struct is given a name, car, right? So car, I don't know, car1. So I have just declared a structure of type car and given the name car1. Let's say I'd like to fill in the variables. Car1 is dot number of wheels is 4. Car1, so I refer to the properties of the car using the dot. So dot, go inside the scope of the struct and access the different properties. So car brand is, I don't know, Mercedes. Car1 dot color is black, and car1 dot max speed is maybe 300. Okay, so now at this point of code, run. At this point of code, I have stored inside car1 the different values of the properties. Now, if I want to call print properties, all I have to do is car1.print properties and run, and there you have it. So we go here, brand is Mercedes, number of wheels is 4, color is black, and max speed is 300. You can also print within the main using, let's say, car1 dot, I don't know, max speed within the main scope as so, 300, right? You could also include pointers and print a pointer. The value of a is equal to the value of a, right? So there's an error because we did not fill in the value of a. Dot a is equal, let's say, to address b, and int b is 1. Right, so let's say I change the value of b again to 10 here. Value of a is 10 because the pointer a is pointing at b. Let's remove this. This means that I could create pointers as follows. Let's say I would like to have a chain of cars. They're connected to one another. So what I can do is this. Car star car. As so. So what that means is the structure car has those properties, and we have this method, if you will, that prints the properties of the car. And there's one more property which is also of type car, but it's a pointer pointing towards another car. So with that being said, let's create another car. Let me type here a method instead of having to type in repetitive code. Let's type a method saying create car, and it should return a car. So let's create car and fill in what we have to fill in. So I'll copy paste everything here, remove this, create the car, fill in the properties of the car, and fill in maybe car dot car, this one, right? I don't know, put it null for the moment. which means point nowhere, just to make sure that everything is properly initialized. And I do not want to each time create a Mercedes car which is black, has 4 wheels and 300 max speed. No, I want some flexibility within my function, so I'll pass those parameters as, arguments. Number of wheels, brand, color, and max speed. And right here, number of is equal to number of wheels. Just to avoid confusion, I'm going to name them something else. Number of wheels and brand uppercase, color uppercase, and max speed camel case. And I have to finally return the car, right? When I call this function, new car is created, and the following arguments are passed as properties to our car. And finally, the car that points towards another car is set to null for the moment. Car is equal to create car, and pass the arguments for brand Mercedes, color black, and max speed, let's say 300. Run, all executed properly. Now let's print the properties. There you have it. Okay, so let's create 2 other cars, and let me name this one car 1. So car 2 is create car. Say I have a car of 6 wheels. It's a BMW, which is yellow, and max speed is 400. Let's print all the properties. One more thing, see out. This car is pointing at car. Run. So 0x0, in other words, is pointing at null, right? Okay, now let's figure out a way to link all those cars in one chain, meaning that I want to access car 2 from car 1 and car 3 from car 2 and so on. So how do we do that? Remove this first. Then I want car 1 dot the property car to point at car 2. And I want car 2 dot car to point at car 3. Now we should have all the cars connected via car 1. So car 1 is connected to car 2 and car 2 is connected to car 3. Let's demonstrate this. See out car 1 dot its property car, which is the other car connected to it, dot, let's say, number of wheels, right? Here I have an error. Maybe we should use this. Yes. So run, and there you have it, 6. So what happened here is car 1 has a property car which is set to car 2. Now since we're using pointers, we should access using the arrow notation and not dot notation. So everything using pointers or addresses, you should be using the arrow notation. Let's print other properties. Let's say I want to print the brand and the color. What else? Max speed, right? So run, and there you have it. This is the car connected to car 1, which is BMW 6 yellow 400. Now let's access the third car connected to car 1. Car 1 dot car. It's the car connected to the car connected to car 1. So you can do this, run, and there you have it. So it's 3, Renault, Magenta, 200. And to print the properties of the car itself, I'll print it first here. We'll remove all this. So it's directly the max speed of this car. So really, this is a way to connect structures to one another. So here you have it. This is the first 4 lines of printing right here. Then comes car 2, then car 3. So I'll insert some comments right here. A natural question that you might ask is, how do I print so using a loop? Well, that's a nice question. And the way you can do so is as follows. Let's declare a temporary car which will loop over all the cars until it will be null, while temp not equal to null, because that's what the address of the last car would be. So car 3 right here is the last node of the list, if you will. So car 3 was created right here using this function, and as you can see, the car property of itself is null, whereas the other car properties are not null. They, on the other hand, point towards other cars, right? So how do we do that? While temp is not null, temp is equal to address of car 1, then temp dot print properties. I don't want to do this. I would like to do that. Then temp is not car 1 right now. It should be assigned the value of the next car. Let's see if that works. Run. Oh, so temp should be initialized outside. My bad. So we can do this. Of course, temp is null because we didn't initialize it outside. Like when we had this block of code right now and we run it, temp is null because we didn't give it a value, right? So let's initialize it here and do this. Run. Voila. There you can see it. Let me insert some dashes, and right here let me insert a certain counter and counter is 1. First time we enter the loop, we're going to print iteration number counter, right? Let's insert some dashes right here and right here. And at the end, you would want to increment your counter. So run, there you have it. Now let me remove this because it doesn't look good. So at the first iteration, we're printing car 1, second iteration car 2, and third iteration car 3. Without having to access car 1, 2, 3 directly, we access the properties using only the temp. So this is like an array of cars. Notice that car 3 is pointing at null, which is nothing. 0x0, the address of nothing. Okay, let's talk about classes. Okay, so classes are really similar to structures, except that they could inherit from one another, and they have other similarities and differences we'll be talking about in later lectures. So to define a class, the blueprint is as follows. So let's say I want to define a class of vehicle as so. So every class has properties and methods similar to structs. You could mark them as private and public. So private, public as so. Those are keywords. And private are basically properties and methods that you cannot access within your main. So let's say I want some private methods or properties such as number of wheels. I would like to know how many windows I have, number of windows. Is my car convertible? Is convertible. Let's say I need a double of max speed. All those properties, since they're marked as private, this means that we cannot access them within the main. On the other hand, if your properties are public, you could do so. So let's say int size. Since size is marked as public, we can access it from the main. So let's create a vehicle class. So vehicle, lowercase vehicle. Let me clear all this. Okay, so run, and we have created a vehicle. Now let's check. Can we access the private ones? No, we cannot. We can see that there's no suggestions. And if we want to access them, number of wheels is equal to 2, for example, you would see that there's an error. Run it, and there you have it. It's private. On the other hand, you could access size because it's public. Run, and there you have it. Now, this notion of private-public duality is related to data encapsulation. So it's a way to hide your data from other users. Now, how do we set and get those properties within the main? Using methods. Let's create some public methods to get and set. So I call them getters and setters. Getters is to get their values, and setters is to set their values. So getters, I would like to get the number of wheels as so, and return number of wheels, right? So those are my getters. They return the data types of their corresponding properties. So since number of wheels is an int, this method should return an int, which is the number of wheels. Now setters, on the other hand, will set those private properties. If you want to set number of wheels, you have to pass how many wheels you want. Then you would set number of wheels to the argument you just passed. Let's do the same thing for the other three. Set number of windows. So number of windows, which is a private property, should be equal to windows, the argument we passed, and so on. Good. Now let's print some stuff. So cout number of wheels. So get number of wheels, right? Because we want to get it. Let me copy paste this 4 more times. Number of windows, convertible, max speed, and last but not least, the size. So let's set our vehicle dot set number of wheels to 4, set number of windows to 2, set convertibility to true, and set max speed to 200. Last but not least, the public one, which is size, set it to, I don't know, 3, and then you would want to print run, and there you have it. Okay, 4, 2, 1. 1 is true, 0 is false, 203. You could also include some constructors and a destructor. So a constructor is a method that is called upon creation or instantiation of your class. Vehicle here, lowercase. So how do we write a constructor? It's as simple as writing the name of your class followed by parentheses, and then the block of code that you want to be executed upon creation of the class. So how do we do that? Let's just type in something like object of the class has been created. As simple as that. So run, there you see it. This executes right here. To see that it does, just type in a cout saying this is right after creation. Run, there you have it. This is how you do a constructor. There's another way of doing it. Depends what you prefer. You can do this. Without typing in the functionality inside, all you have to do is type in a prototype, the signature of your constructor, which is this. And right after the class, so right after line 38, let me zoom out just so that you can see. So this is your class, vehicle, all this. Right here, all you have to do is type in the name of the class, then the name of the method, which is also vehicle, right? So what you need to do is type in the message, object has been created, and don't forget the semicolon, run, and there you have it. Let's say you wanted print properties to have a prototype, then you can do this. So remove all this, then vehicle, followed by 2 colons, followed by the name of the method, paste. So you've got to include the return type, void. So void as in void right here. Then you have to say that this method is coming out of the class vehicle. Perfect. So let's run, and there you have it. So object of the class has been created thanks to line 42. Then all this is setting the different properties of vehicle, and then we print the properties using this method right here. So that's about it. So let's talk about destructors. What are destructors? So in contrast to constructors, a destructor is a method that is executed when the object has been freed from memory or destructed. And this happens, for example, when the main function has done executing, or when an object of the class has been declared within a scope of a function. Let's say the function is here, void a function, and I have a certain vehicle, let's call it truck, and I do some stuff with truck. And then when the function has done executing, when it reaches line 46, for example, then the truck is destructed, meaning that it is freed from memory. So the following method, which is destructor, will be called automatically without you having to call it. So how do you define a certain destructor? All you have to do is type in tilde followed by the name of the class, vehicle, and that's it. Okay, this is a prototype. You can go ahead and type in the functionality right here and type in a message saying this object has been destructed. To be more consistent, let's be more precise on something. Let's give this vehicle an ID and create a getter and setter. Get ID, pass it nothing, return ID, right? And void set ID, pass it an ID. And what you want to do is set the ID. In properties, you'd want to print the ID as well. And finally, pass the ID to the object. Set ID to this random number right here. Could be a plate number or whatever uniquely points at the vehicle. Okay, now let's run it. So my ID is this, all those are the properties, and as you can see this object has been destructed. But let's be more accurate about that. Let's say I want to print the ID of the object that has been destructed. Otherwise, if I have, let's say, 100 objects within my main and some of them were destructed due to some reason, then this useless message is printed. This object. Well, which object? You have to tell me. So to do that, all we have to do is change the message to the object of ID has been destructed. And let's say you have other classes that also include ID, so let's be more accurate here, of ID which belongs to the vehicle class has been destructed. Okay, let's give it a shot, run, and there you have it. This is the ID of this vehicle, right? You can also go ahead and include a prototype of the destructor as so. Given that, you will write the method just here. Let me paste this here and let me copy paste the signature of the method right here. Okay. Let's run, and there you have it. I could remove the semicolons right here, by the way, or I could include them, whatever. To demonstrate what method overloading is, let's create a new script called method overloading, just to tell you what it is. Okay, so method overloading is when you have methods of the same name but different signatures. So what is a signature? Let's say void my function. It's called my function. This is the signature. Void my function. So void my function is going to print out I am in function number 1. Let's say I have another function of the same name, but you should give it different arguments. So let's say you pass it an integer, cout, you print I am in function number 2 where a is equal to a, and the list goes on. So you can pass int a and a boolean as well. I'll copy paste all this. I am in function number 3 where a is so and b is so. Let's see what happens if I call my function as so. The first function should be executed. I am in function number 1. If I pass it an integer, let's say 1, then this function should be executed. I am in function number 2 where a is 1. Let's pass it a boolean. True. I am in function number 3 where a is 1 and b is true. So this is what method overloading is. And in case you were wondering, what if I create the same signature as so and say I am in function number, I don't know, 4, then you'd get an error saying previous definition is here. So why are you defining the same function twice? You should not. So this is what method overloading is. Let's go back to classes. And to demonstrate this, it's a nice way of creating several constructors. So let's say I have a vehicle. I want to pass it the ID upon creation. So all I have to do is set ID to the ID I just passed. So this is an instance of method overloading. I'm creating the same method twice but with different arguments, which means that right here I could save this line and pass the ID upon creation, which is cool, right? This means that the following code corresponding to the first constructor will not be called because we are calling second constructor, which is this one. So to show you what I mean, let's run, and there you have it. We weren't greeted with this message, object of the class has been created. No, because this is the constructor that has been called. We did not print any message. If you wanted to print a message to show you the difference, let's print this. I am in constructor number 2, right? And there you have it. Let's include a prototype so you can do this. Vehicle again, int ID, set ID to ID, and remove all this including your ID right here. So all you have to do in prototypes where you're passing arguments, just include the data type of the argument. And right here, let's say constructor number 1, and over here constructor number 2. So run, there you have it. Constructor number 2, we have set the ID automatically upon creation. Let's do other stuff. Vehicle int. If you want to pass 2 integers, let's add this block of code right here. Int ID, let's say you would like to pass number of wheels, then you'd say here set number of wheels to number of wheels that you just passed. Let's continue the list. Each time we increase vehicle int number of windows. This is constructor number 4. So set ID, set number of wheels, and set number of windows to number of windows. So let me show you what I mean. Let's remove this, pass them as arguments. So let's pass 4 and 2. Run, and there you have it. So this is the ID, number of wheels, and 2. You can continue the list right here and keep on adding, or if you want, just automatically include all your properties as arguments when you want to create the class. So let's do that. I'm going to create 5, add bool is convertible, and set, it's yelling at me right here because I did not include the prototype yet. Vehicle int and a bool. So int bool, set convertibility to is convertible. Let's copy paste this again and add a double, which is max speed, and set it right here. Max speed, then go here to include the prototype or the signature, whatever you want to call it. And the last one is including the public property, which is the size, and have it include a last int, which is the size. So going back here, I'll copy paste the last constructor and say that it's number 7, and have it include the size and say that size is size. What do you think? So let's pass all the properties right here, remove all this, run, and everything is correct except one thing, which is the size. And why is it so? Because I just said size is size. Does that make sense? No, it does not. So what do? We should discriminate between the two sizes. So I could say int size as so, and say that this size is equal to that size, so run. There you have it. Or I could keep size lowercase, but to differentiate between this size and this size, so obviously you mean by this size the property of the class, and this size right here you mean the argument, so you should do this dot size or arrow size, run, and there you have it. Okay, so this arrow size means the size within the class, whereas this size means the argument. Now of course this seems easier, but it's nice to know how to reference different variables of the same name. I'm going to do some feature of VS Code, which is, it's an extension you could install, which is called code folding. I could fold my code as so, just for organization's sake. And this is my main right here. Okay, and this is my class. So as you can see, I have 7 constructors. You could also do the same thing with destructors, but I think you get the point. Let me reopen them, see what's going on. Let's talk about static variables. So what exactly are static variables? Well, it's a variable that is shared among all objects of the same class, and that's why it's a static. So static, let's say I want to keep track of the number of vehicles created within my program or within my main. How do I do so? So the simplest way is to create a static variable, let's say number of vehicles, and I do not want to initialize it inside, because if I do so, then each time I create a vehicle, number of vehicles will be set to 0. So to avoid this confusion, let's define it or initialize it outside. So int vehicle, 2 colons, then let's point towards number of vehicles is equal to 0. That's an initial value. Note that I'm writing this outside the class and also outside my main. Let me show you how I do that. Let me just fold my code. So these are all the constructors defined outside the class. This is print property defined outside my class. This is my class, okay? And here's my int vehicle, right? So since I defined it as private, I need a getter for it. So the getter should also be static. So static return type, which is int, get number of vehicles, then return number of vehicles, right? We should note that each time we create a vehicle, as such, we should automatically increment number of vehicles. So let's write a method for that. So there's 2 ways of doing so. You could go inside each constructor, and at the end of each constructor increment the value vehicle, 2 columns, then number of vehicles plus plus. Now note that here I'm incrementing the value with, but you should keep in mind that all this code written in the constructor is seen within the class, right? Because it's a constructor of the class. So I'd want to increment it here and here as well. So within each of my constructors. So this is not a practical way. I'm just doing so to show you my point. And not just that, I want to decrement it each time I destruct an object of the class. So I'm decrementing it at the destructor. Let me add it to print properties right here. Number of vehicles is number of vehicles. So let's run this. There you have it. Number of vehicles is 1 because I created 1. Now let me create another one right here and give it another ID. 300 max speed. Size is, let's say, 4. False to convertibility. Let's change number of wheels to 6. Number of windows to 4. Then print the properties again, right? So run. I should give it another, so vehicle 2, because vehicle is already defined. So run. There you have it. Number of vehicles is 2. It would be really useful to also print the number of vehicles upon destructing, right? So number of vehicles now is, I could also go ahead and remove this vehicle. So run, and I could remove vehicles right here, but it's just emphasizing that the number of vehicles is static. And that's why we put vehicle with 2 columns. As you can see here, this is the first printing. Up till now, the number of vehicles is 1. The second printing is right here. You can see number of vehicles is 2. Then, since we're returning 0 at the end of the main function, it's now time to destruct our vehicles. So it's decremented 1, then 0. Let me show you where this has a useful case as well. Function create, sorry, not function, void create temporary vehicle. Let's pass it an int ID, int number of wheels. Number of windows is convertible, max speed, last but not least, and size. And right here I do this. Vehicle is, I construct it, ID, number of. So here I'm creating the vehicle within the scope of this class. Create a temporary vehicle, right? So let's see what happens here. it's really nice to note that the vehicle is going to be destructed before the main is terminated. So let me create it here and let's see what happens. Run. So constructor number 7 is called, and as you can see here, something really nice to observe, the object of ID 137192, which belongs to the vehicle class, has been destructed, and now the number of vehicles is set to 0. Let's do a print of this vehicle right here. Vehicle.print properties, right? So run. So it's 1, number of vehicles is 1, and then it's 0, because when this function is done terminating, the vehicle is destructed, and therefore the destructor is called, and finally the number of vehicles is 0 again. Okay, let's talk about class inheritance. Before we do that, let me organize the code a bit right here. Let's get rid of that. Okay, and let's fold the code right here. Give me some space right here. Perfect. So let's say you have another class that you want to create which shares the same property as the first class, vehicle. So in that case, vehicle would serve as a father or superclass to the inheriting class. For example, if you want to create a car class, a car is a vehicle. In that case, we say that car inherits from vehicle. So with that being said, all the properties and methods of vehicle are shared by the class car. So car could access all the properties and methods of vehicle. It's as if we copy pasted everything written for vehicle to the car, and you can go ahead and add the car's special properties / methods, right? So how do we do that? Let's say class car will inherit using a colon. You could say inherit from the public class, which is vehicle, right? Doing that, you could now create a car that shares the same properties and methods of vehicle. So let's not forget the semicolon after we create the car right here. So let's add some properties and methods that are special to the car. So let's say the car has a certain model. So string model, right? We'd like to keep it private. Since model is private, we need getters and setters. So a getter and a setter for the model string. Get model and set model. Okay, let's say you would like to have a constructor and you'd like the same constructor of vehicle. So I'm not going to add all of those, no. I'll add just the last one. So we need all the properties here to be set in addition to the model. Okay, so how do we go and do that? In case you would like to override a method, car, you take all the properties right here that you need from the vehicle. We want to set all those in addition to the model. So we want the vehicle constructor to execute, and we pass it all this. ID, number of wheels, number of windows is convertible, max speed, and size, right? And we want one more thing, is to set the model by passing this model in the constructor right here, and there you have it. So I'm just going to do a small modification for print properties because it's been annoying me from the start. I don't know why I didn't do it. So I'll add some dashes, right, and say info. Let's create a car. So car. Let me copy paste all those properties, give it a random ID, as so, and let's say this is true. Just to show you the difference, say it has 4 windows, 4 wheels, and we need one more property, which is the model. Let's say it's a Ferrari, as so. And let me print the properties. So remember, since car is inheriting from vehicle, I could run this method as well, as I'm using a vehicle. So run, okay, here we have it. This is the first print property, second print property, and the third one. Constructor number 7. So this is the first printing. We talked about this, and we also talked about this. Now this one is for the car. It's the same method being run. We have one more property, which is model, and it's not being printed because property is not found in vehicle. So we cannot go ahead right here to the print properties and say cout blah blah blah, then I don't know, model. It doesn't work, right? Because this is a vehicle, it's not a car. So how do we do that? You can do that simply by including the same function name print properties. We should include the return type. So it's a void as so. And right down here, you could do car print properties. Don't forget the void. And you could call print properties of the superclass, which is vehicle, and here you could print car property, which is model. So model get model. We should be able to see beneath this line the model. Did we see it? No, we did not. I think it's this. So run. Yep. So how do you call the superclass print property? By using vehicle and two columns, right? So you can't just say print properties because this would lead to confusion. Print properties, you have now two methods. You have one for the class and one for the class car and one for the class vehicle. So if you go ahead and say print property as so, as we did previously, it would lead to an error. So you have to state explicitly that this print properties is the one coming from the vehicle. On top of that, I'd like to also print my model. So there you have. That's basically it. This is how you inherit from another class. Just go ahead and add its special properties and methods, if you will. And that's basically it. So before I talk about virtual methods, I'm just going to point something really important. So let me get rid of all this code in the main. And let's say we're stumbling across this situation where I create a vehicle and I pass it all what it needs. And I have a function which basically accepts a vehicle as a parameter. So void a function that accepts a vehicle. Okay, so vehicle v, and just for argument's sake, let's say this function prints the properties, right? We're not calling this function yet. Run, and as we can see, constructor 7 is called, and it's destructed because we reached return 0, and the number of vehicles is now 0. So let's now call the function and pass it the vehicle object as such. We have a problem here. Number of vehicles is now -1. So let me just remove print properties to show you what I mean. This object is destructed twice. And why is that? Well, simply, as we said before, the destructor is called when the object is destructed. So once we call this function and pass it a vehicle by value, and value is a keyword here, and when we pass it by value, as so, upon execution of the function, a copy of this object is destructed, because if we pass something by value, a copy of this something is created. So everything within this class vehicle is copied to v, and when this function is done, then v is destructed. Hence, the number of vehicles is decremented, and when we reach here, return 0 in the main function, destructor is called again, and the number of vehicles is decremented again. So how do we solve that? One way to solve it, you can pass a pointer, a vehicle to be a pointer, and then pass your vehicle by address as such. Running that would solve the issue. And what just happened here is that this function accepts a pointer towards a vehicle, therefore no copy is created, and therefore when this function is done, the destructor will not be called. It will be called only once at return 0 of the main function. That's a really important point to keep in mind. When you want to pass the vehicle by value, then you're destructing a copy of it, and therefore you should bear the consequences of the destructor method. If you do not want the destructor, on the other hand, to be executed, then you should not pass it by value. So this is it. This is all you need to know before we start with virtual methods. And another point to keep in mind is the difference between method overloading and overriding. So method overloading is when I have a method that is implemented multiple times but with different arguments. This is overloading. Whereas overriding is when you have the same method implemented in two or multiple different places, but one in the superclass and the other one in its subclass, or the class that it inherits from it. So an example of this that occurred is the print properties. So the print properties occurs in the vehicle class, right? And it occurs again in the car class, which inherits from vehicle. So here we have void properties in the car class, which is implemented right here. As you can see, it calls the superclass vehicle to execute the print properties, and on top of that we print a new line which includes the model of the car, right? So that's also a really important point to keep in mind, the difference between method overloading and overriding. Okay, so let's talk about virtual methods. First of all, let me get rid of this method right here, and it's calling line. So let's say I'm in a situation where I would like to override a method. Let's go to the base class, which is vehicle. Let's say I would like to create a public method called getMyClass, which simply prints the class I am in. I am a vehicle. And we've got the same method in car. This time I am a car. So let's create a car now. Let me copy paste those and do some minor changes. Let's run to make sure everything is good. Okay, everything seems good. And now let's call getMyClass and vehicle getMyClass, right? Now let's run it and it works properly. Okay? Now you're going to stumble across this problem maybe within your coding experience. Let's say you would like to have a function that tells you who am I, okay? It accepts a vehicle. So let's get rid of this and let's call this function first time on a vehicle. And in case you're wondering, you could also pass it a car, right? Because a car is a vehicle, but a vehicle is not a car due to inheritance. So running that would give you I am a vehicle twice because a car is a vehicle. And we have this problem of -1, -2, which we talked about, which can be solved as follows. Pass a pointer and pass the vehicle and the car as reference. Instead of a dot, you should use an arrow because it's a pointer. We talked about this when we use structures. So run this and the issue of negative number of vehicles is solved because the destructor is not called more than it should be called. But we have this problem. So I am a vehicle twice. A car is not a vehicle, but the method getMyClass is being called from the superclass instead of the subclass. Now this is a problem, and the only way to solve this is by using the virtual method. So going up to the base class, which is the vehicle, all you have to do is mention the keyword virtual next to the getMyClass. Going back down and running, this will solve the issue. So that's about it. That's how virtual methods work. I'll see you in the next one.
Thank you very much for watching this lecture. It means a lot that you've made it so far, and I hope that this lecture was useful and it could help anyone out there struggling with C++, and in particular anything on pointers and object-oriented programming. Remember, I could respond to emails or comments that have to do about the lecture. If you have anything in mind, I could create a video on that topic. You could just leave a comment or send me an email. What is it that you're struggling with? And I'm open to all suggestions on C++ and other topics related to programming or even mathematics, electrical engineering, and all these kind of good stuff. Again, thank you for watching, and I'll see you in later lectures. Thank you so much. And have a happy new year, because we still have what, at the day of recording this lecture, we still have like, I don't know, 2 more days for New Year's. So happy New Year's. Okay, so I'll see you then.